Welcome to Suhail Khan Official 07, the channel dedicated to helping you thrive in the oil and gas industry. Today we're tackling a crucial step in your journey, the OCTCO exam. Passing this exam is your gateway to a world of opportunities with Oil Country Tubular Corporation, a global leader in oil field equipment. Whether you're just starting out or looking to advance your career, acing the OCTCO exam is essential. That's why we've crafted this comprehensive guide, packed with essential questions and answers to boost your confidence and ensure you're fully prepared. Don't forget to hit that subscribe button and turn on notifications so you don't miss out on any future videos filled with valuable insights and tips for success in the oil and gas sector. Let's dive in. Let's kick things off by understanding the fundamental role of casing in oil and gas wells. Imagine drilling a deep hole into the earth. You need something strong and reliable to prevent that hole from collapsing in on itself, right? That's where casing comes in. Think of casing as a protective shield, a structural backbone for the well bore. It's like the foundation of a skyscraper, providing the necessary support to keep everything stable and secure. Without casing, the well would be highly susceptible to collapse, jeopardizing the entire drilling and production process. But it's not just about preventing collapse. Casing also serves as a barrier, isolating different formations within the well. This is crucial for preventing contamination of freshwater aquifers by oil or gas, ensuring environmental safety. Furthermore, casing protects the well bore from the corrosive effects of the fluids and gases it encounters deep underground. This is particularly important for maintaining the long-term integrity of the well and maximizing its productive life. Now, the primary function of casing, the one you absolutely need to remember for the OCTCO exam, is to provide structural integrity. This means ensuring the wellbore remains intact and stable throughout its operational life, from drilling to production and even abandonment. Remember, a well without proper casing is like a house built on sand. It's just a matter of time before things go wrong. So, when you see a question about the primary function of casing, think structural integrity, the backbone of any successful well. Understanding the vital role of casing is fundamental to excelling in the OCTCO exam. It demonstrates a grasp of well construction principles and the importance of safety and efficiency in oil and gas operations. Keep in mind that the OCTCO exam tests your knowledge on real-world applications, so try to visualize these concepts and relate them to practical scenarios. This will not only help you remember the information, but also demonstrate a deeper understanding of the subject matter. Now that we've covered the crucial role of casing, let's move on to another essential component of the oil and gas industry, the pipes used for transporting these valuable resources. Now that we've covered the importance of casing, let's talk about transporting the oil and gas we've worked so hard to extract. This is where API 5L pipe comes in, the workhorse of the oil and gas industry. API 5L pipe is specifically designed to handle the unique challenges of transporting oil and gas, from the wellhead to refineries and beyond. It's built to withstand high pressures, extreme temperatures, and the corrosive nature of hydrocarbons. But what makes API 5L pipe the industry standard? It all boils down to standardization and reliability. The American Petroleum Institute, or API, sets stringent manufacturing and testing standards for API 5L pipe, ensuring its quality and performance. This standardization is crucial for interchangeability and global trade. Imagine if every pipe manufacturer had its own specifications. It would create chaos in the industry. API 5L pipe provides a common language, ensuring seamless operations worldwide. Now let's talk about the different grades of API 5L pipe. These grades, designated by letters like X42, X52, and so on, represent the pipe's minimum yield strength, a measure of its resistance to deformation under pressure. The higher the grade, the stronger the pipe. Choosing the right grade depends on factors like the pipeline's operating pressure, the type of fluid being transported, and the environmental conditions. Remember, using the wrong grade of pipe can have disastrous consequences, leading to leaks, spills, and even explosions. That's why understanding API 5L pipe specifications is crucial for anyone working in the oil and gas industry. So, when you see a question about the type of pipe commonly used for oil and gas transportation, confidently answer API 5L pipe. It's the industry standard for a reason: reliability, standardization, and safety. Mastering the intricacies of API 5L pipe is essential for succeeding in the OCTCO exam. It demonstrates a solid understanding of pipeline engineering principles and the importance of using the right materials for the job. As you prepare for the exam, focus on understanding the key properties of API 5L pipe, its different grades, and the factors influencing pipe selection. This knowledge will equip you to tackle any questions related to oil and gas transportation. With a firm grasp of API 5L pipe, you're well on your way to conquering the OCTCO exam and embarking on a successful career in the oil and gas industry. Now let's delve into the distinctions between two other critical components, tubing and casing. We've talked about casing, the protective shell of a well, and API 5L pipe, the workhorse of oil and gas transportation. Now let's clarify the difference between tubing and casing, two terms that often cause confusion. Think of it this way. Casing is the permanent infrastructure of the well, while tubing is the conduit for production. Casing is cemented in place, providing structural integrity, while tubing is lowered into the well after casing is set. Tubing's primary function is to transport the produced fluids, mainly oil and gas, from the reservoir to the surface. It's like the veins and arteries of the well, carrying the lifeblood of the operation. Casing, on the other hand, is like the skeleton, providing support and preventing collapse. It's a larger diameter pipe that's cemented in place, creating a secure barrier between the wellbore and the surrounding formations. Here's a simple analogy. Imagine a multi-story building. The casing is like the building's foundation and structural columns, while the tubing is like the plumbing system that carries water to different floors. Understanding the difference between tubing and casing is crucial for the OCTCO exam. You might encounter questions about their respective functions, materials, or installation methods. Remember, tubing is for production, while casing is for well construction and integrity. Keep this distinction in mind and you'll be well equipped to tackle any questions related to these essential components. Now let's delve deeper into the characteristics of tubing and casing. Tubing is typically made of steel, but it can also be made of corrosion-resistant alloys depending on the well's conditions. Casing, on the other hand, is almost always made of steel due to its strength and durability. It needs to withstand immense pressure from the surrounding formations and the weight of the well itself. Another key difference lies in their installation. Tubing is lowered into the well bore and connected to the wellhead using a system of threaded connections. It can be pulled out and replaced if necessary, offering flexibility during the well's life. Casing, however, is cemented in place, creating a permanent seal. This process involves pumping cement slurry into the annulus, the space between the casing and the well bore, to prevent fluid migration and ensure well integrity. Mastering the nuances of tubing and casing will undoubtedly give you an edge in the OCTCO exam. It demonstrates a comprehensive understanding of well construction, production principles, and the importance of using the right materials for specific applications. We've discussed the importance of casing and tubing, but how do we ensure these tubular products can withstand the immense pressures and stresses encountered deep underground? That's where stress analysis comes in, a critical aspect of oil and gas engineering. Stress analysis is like giving these tubular products a thorough medical checkup. It involves using mathematical models and engineering principles to calculate the stresses and strains they'll experience during operation. Imagine a weightlifter lifting a heavy barbell. The barbell exerts stress on the weightlifter's muscles and bones. Similarly, the weight of the well, the pressure of the fluids, and even temperature changes exert stress on casing and tubing. Stress analysis helps engineers determine if these stresses are within safe limits. If the stresses are too high, it can lead to deformation, cracks, or even catastrophic failure of the tubular products. Think of it like this. You wouldn't want to stand on a bridge that hasn't been stress tested, right? The same principle applies to oil and gas wells. Stress analysis ensures the structural integrity of these critical components. Now let's talk about the factors considered during stress analysis. These include the well's depth, the pressure and temperature of the fluids, the weight of the tubular products themselves, and even the geological formations surrounding the well. Engineers use specialized software and industry standards, such as those developed by the American Petroleum Institute, or API, to perform stress analysis. These standards provide guidelines and formulas for calculating safe operating limits. The purpose of stress analysis is not to over-engineer the well, but to optimize its design and ensure its safety and reliability. It's about finding the right balance between strength and cost-effectiveness. understanding the principles of stress analysis is crucial for the OCTCO exam. It demonstrates a grasp of the engineering challenges involved in oil and gas well design and the importance of ensuring structural integrity. Remember, stress analysis is not just a theoretical exercise. It has real-world implications for the safety of workers, the protection of the environment, and the economic viability of oil and gas operations. By mastering the concepts of stress analysis, you'll be well prepared to answer questions related to well integrity, tubular design, and the factors influencing the safe operation of oil and gas wells. We've covered a lot of ground, from the role of casing to the importance of stress analysis. Now, let's focus on a practical skill that's essential for anyone working with tubular products: calculating pipe pressure rating. Pipe pressure rating is like a speed limit for pipes. It tells you the maximum pressure a pipe can safely withstand at a given temperature. Exceeding this rating is like driving too fast. It can lead to dangerous consequences. Calculating pipe pressure rating is not about memorizing complex formulas. It's about understanding the factors that influence a pipe's strength and using industry-standard formulas and tables to determine its safe operating limits. The American Petroleum Institute, or API, provides comprehensive guidelines and formulas for calculating pipe pressure rating. These formulas take into account factors like the pipe's material properties, wall thickness, diameter, and the temperature of the fluid it's carrying. Think of it like baking a cake. You need the right ingredients in the right proportions to get the desired result. Similarly, calculating pipe pressure rating involves plugging in the right values into the API formulas to determine the pipe's safe operating pressure. Let's break down the process. First, you need to know the pipe's material specification, such as API 5L grade B. This specification tells you the pipe's minimum yield strength, a measure of its resistance to deformation. Next, you need to know the pipe's dimensions, its outside diameter, and wall thickness. These dimensions determine the pipe's cross-sectional area, which directly affects its pressure-carrying capacity. Finally, you need to consider the operating temperature. Higher temperatures can reduce a pipe's strength, so the pressure rating needs to be adjusted accordingly. Once you have these values, you can refer to the API tables or use specialized software to calculate the pipe's pressure rating. These resources provide pre-calculated values based on the API formulas, simplifying the process. Understanding how to calculate pipe pressure rating is crucial for the OCTCO exam. It demonstrates a practical understanding of pipe mechanics, safety standards, and the factors influencing a pipe's ability to withstand pressure. Remember, working with pressurized systems can be dangerous. Calculating pipe pressure rating is not just about passing an exam, it's about ensuring the safety of personnel, protecting the environment, and maintaining the integrity of oil and gas operations. Congratulations on completing this comprehensive guide to acing the OCTCO exam. You've gained valuable insights into key concepts, from the role of casing to the importance of stress analysis and pipe pressure rating. Remember, success in the OCTCO exam requires more than just memorizing facts. It's about understanding the principles behind the concepts and applying your knowledge to real-world scenarios. We're confident that the information and insights shared in this video will equip you to confidently tackle the OCTCO exam and embark on a rewarding career in the oil and gas industry.